Okay, so as I said, many of you are plugging the A, B, and C that you get from your function into the quadratic formula. Okay, so that's okay, that gives you information. It tells you whether you have zeros, real zeros, and it tells you where they are. And of course, you could take those 2 points and then move your fingers at exactly the right speed and find the vertex, axis of symmetry, right? It is worth understanding that. But to find the vertex, you can isolate just what I circled in red, or whatever that color is, reddish pink, pinkish red, and find the axis of symmetry. And to find the vertex, it says to find the vertex, you find the axis of symmetry, right? So, okay, there's your vertex, right? I mean, there's your axis of symmetry. Then plug in x equals 3. Plug it in. Do the arithmetic, you get 27 minus 54 plus 17. I saw at least one person had negative 10. I looked at it carefully and said, yeah, he can do arithmetic. Okay? And then some of the rest of you got it, okay? This is very good, very good. Okay, so what's the axis, so what's the vertex? So now we know something about the graph of this function, right? Okay, so now the graph of the function. Okay, vertex is at x equals 3. Okay, so I'm going to put x equals 3 here. That's the axis of symmetry. I said the vertex is at x equals 3. It's on the line x equals 3. Axis of symmetry is x equals 3. Okay? Vertex. Well, the y-coordinate is negative 10. Okay, so let's say negative 10 is here. Now, anything difficult about that? Really simple, isn't it? If you know the quadratic formula, you know how to find the expression for the vertex. You don't have to memorize an extra expression for the vertex. It's sitting right there smiling at you, halfway between the two zeros, as we explained. Okay? So if you want to memorize this and memorize this, go ahead, but this is in there. Okay, so we use that to find the vertex. Again, that's really easy, but you got to remember what you're doing. And to remember what you're doing, you really need to understand what you're doing. Okay. Now, some of you went ahead and found the zeros. Okay? That's more information. So, the zeros are at negative 3 plus or minus the square root of let's see, B is 18, so that's 324. AC is 51, so that would be 153. No, 4 times that'd be 204, right? Over 2 times 3. I really can do arithmetic. Pay attention. And that's 3 plus or minus the square root of 120 over 6. Okay? Well, that's 3 over 6 plus or minus the square root of 120 over 6. 3 over 6 is 1/2. The square root of 120 is just shy of 11. It's 10.95 probably. Okay? And the square root function is concave down, as you know from the basic functions. So a straight line from the x equals 10 to the x equals 11, or the x equals 100 to x equals 120 point is going to be a little above or a little below the curve. So that could be, it's a little more than 10.95, but I'm not sure it goes to 10.96. Okay? And you should understand the basic functions well enough to think like that by the time we're done with this course. You should be able to visualize the square root function and make a good estimate, because you know that 10 squared is 100 and 11 squared is 121. If you don't know your squares at least up to 12, you should. Okay? Anyhow, it's this. Okay? Well, that's approximately, just to use reasonable numbers, it's pretty close to 11 over 6, which is 1 5/6, which is 1.83 repeating. So I think it's about 1.83, but I'm just going to use 1.8. So that's about 2.3. Or 1.3, and something's seriously wrong with that, because Vertex isn't halfway between these. Okay? Yeah, Vertex is there. There's something haywire in the arithmetic here. Since it's my arithmetic, there's something haywire in me. What could that be?
Can we divide the square root of 120 by 6 and break that down
Well, square root of 120 is,
to be a square root of 20 instead?
well, you break it down, but the square root of 120, you've got to agree, is either 10.95 or maybe 10.96. That's like 11 over 6, which is pretty close to 1.8. And it's not -3 here. Again, that was careless. It's -18. That's positive 18. It's not 3, it's 18. That's B. I had 3 in my head because that was the axis of symmetry, right? So I pretended to make this mistake to show you need to check your work and make sure it makes sense. Got it? I was just pretending. Okay, so replace this by 18 and we get 3 plus or minus. And it's 3 plus or minus. So it's going to be like 4.8 or 1.2. Is that better? Yeah, see what happens if you concentrate? Okay? Got to do things carefully. Okay, now, if you made that mistake on your test, okay, you'd have done every step right. Now, you're not going to have this problem on the test. This is for next Thursday. But if this occurred in the test and you did everything right and got two ridiculous numbers and didn't show on the graph that those numbers were ridiculous and at least point out, this is ridiculous, that can't be, your axis of symmetry has to be between the zeros, and it ain't, but I can't figure out why. Probably want to take off a point. If you get something ridiculous and don't check it out, you're going to lose half credit on a 10-point problem. Okay? Now that's a plug for checking your work. You want to check things out. And you want to be like some people in this class who've got to see everything right, because that's a really good characteristic. Okay? Me, I just go through, make my mistakes, and see it doesn't work, then I figure it out. Okay? You can choose which strategy you want. If you don't make many mistakes, that's not a bad thing to do, as long as you're checking yourself. Okay? But you probably want to be a little more careful than I am when I'm talking up here. Okay. Now, check it out. If this is your axis of symmetry with the numbers we had there, we have 1.2 and 1.8 or something. Let's say zeros would have been over here. And you know a parabola that has a vertex here isn't going to have two zeros over here. One zero is going to be on this side of the axis of symmetry. One's going to be on the other side of the axis of symmetry. Right? And if it doesn't work out that way, you did something wrong. Okay. So 1.2 would be about here now. So here are zeros. So 1.2 is about there. So there's 3. There would be 4. 5 would be over here, and 4.8 would be about here. Now, can we draw a parabola based on those 3 points? If you got your vertex and your 2 zeros, pretty much home free. Now, you got to be careful that you don't that you get the right y-intercept, which would be 17. So I haven't drawn it really, really well, but based on those 3 points, that's a reasonable parabola. Okay? Make sense?